Alright, we'll continue where we left off. Basically, I have completed the sign chart for the second derivative and have come to the conclusion that f of x is concave down on the interval -1 to -√5/5, and then again from √5/5 to +1. So you may want to take a minute to verify all that information in there. And the next thing that I'm going to do is use all of this information to construct a graph of the function in the next frame. Okay, so we're ready to construct that graph, and one of the first things that I might want to do is to label at least my x-axis with specific values. And the one y value that I am sure of is x equals 0, y equals -1. The points that I can plot are at the zeros of the original function, which are -1, 0, and 1, 0, and the horizontal tangent line at 0, -1. Now we know that the function has a stationary point at x equals -1. It's decreasing up to that point, 0 at that point, and decreasing as a horizontal tangent at that point, and then continues to decrease all the way down to x equals -1, to x equals 0, sorry. Furthermore, we know that from negative infinity up to x equals -1, the function is concave up. So the function is concave up going into x equals -1, has a stationary point at x equals -1, y equals 0, continues to decrease but is now concave down until x equals -√5/5. At x equals -√5/5, the function still increasing but is now concave up all the way to +√5/5, passing through the horizontal tangent line at x equals 0, y equals -1. Okay, at √5/5, the function is increasing, but it is going to change from concave up to concave down and goes in for a stationary point at x equals 1. There it also changes from being concave down to concave up and increasing all the while. So the graph itself is symmetric about the y-axis and is going to end up looking like this. And it meets all of the criteria that we've established in the first part of the problem.